Today, we're showing you how we manufacture a single-core, single-mode drop cable pigtail in our factory. This product uses a 2.0 x 5.2 mm LSZH drop cable with G677A2 bend-insensitive fiber. It is terminated with an SC-APC connector and protected by a Huawei-compatible Mini-SC waterproof housing. It is widely used in FTTH networks, outdoor distribution boxes, terminal boxes, and customer access connections. The process begins by measuring and cutting the cable according to the production order. The operator verifies the required length and inspects the cable jacket to ensure there are no scratches, deformation, or other visible defects. Inside the flat drop cable, strength members protect the optical fiber and absorb tensile force during installation. Before connector termination, the rear boot and waterproof housing components are placed onto the cable. This assembly sequence is important because these parts cannot be installed after the connector has been assembled. Next, a controlled amount of epoxy adhesive is injected into the SC-APC ceramic ferrule. The prepared fiber is inserted through the ferrule until a small amount of adhesive appears at the tip, confirming that the ferrule has been properly filled. The ferrule, spring, and metal connector body are then assembled. The spring-loaded structure provides stable physical contact, while the ferrule will later be polished at an 8-degree angle to reduce back reflection. The operator then measures the stripping length and removes the LSZH outer jacket with a dedicated stripping tool. LSZH, or low smoke zero halogen, is widely used in FTTH installations because it provides improved fire safety. The exposed strength members are trimmed to the specified length, while the fiber coating is carefully removed. The bare fiber is thoroughly cleaned to remove dust, oil, and coating residue before assembly. Next, the crimp sleeve, rear body, and other connector components are assembled. The strength members are positioned correctly, and the operator ensures the fiber is not twisted or excessively bent. Although G677A2 fiber has excellent bend performance, careful handling remains essential. The connector is then placed into a curing fixture. Controlled heat cures the epoxy, creating a strong bond between the fiber and the ceramic ferrule. Both curing temperature and curing time are carefully controlled to ensure long-term reliability. After curing, the connector is crimped using a dedicated fixture. This securely fixes the cable and strength members inside the connector body while providing reliable tensile performance. The crimped connector is inspected before moving to the polishing process. Any excess fiber at the ferrule tip is removed, and the connectors are mounted into a polishing fixture. Several polishing stages using progressively finer polishing films produce the required APC end face. For SC-APC connectors, the 8-degree polishing angle is precisely controlled to achieve low back reflection and excellent return loss performance. After polishing, every connector end face is inspected under a fiber microscope. The operator checks for scratches, pits, cracks, chips, adhesive residue, dust, and other contamination. Any connector that does not meet the inspection standard is repolished or rejected before final assembly. Once the connector passes inspection, the green SC-APC housing is assembled. The ferrule, spring, and locking components are installed correctly to ensure reliable mechanical engagement. Next, the finished SC-APC connector is installed into the Huawei-compatible Mini-SC waterproof housing. The outer housing, sealing ring, locking components, and internal support parts are assembled in sequence to provide mechanical protection and environmental sealing for outdoor FTTH applications. Heat shrink tubing is then applied around the cable entry. Controlled hot air shrinks the tubing evenly, improving strain relief and helping seal the transition between the drop cable and the waterproof housing. The remaining housing components are tightened, and the operator checks the sealing ring, locking mechanism, cable entry, and protective cap to ensure proper assembly. At this stage, the product has reached its final structure. Every completed assembly then undergoes insertion loss and return loss testing. Insertion loss measures signal attenuation through the connector, while return loss measures reflected light. Every finished product is tested to verify that it meets the production requirements. In addition to optical testing, we inspect the waterproof housing, locking function, protective cap, heat shrink area, cable surface, and overall appearance. Finally, the cable length and pigtail end are checked once more. Qualified products are cleaned, labeled, coiled, and packaged according to customer requirements before shipment. From cable preparation and connector termination to polishing, waterproof assembly, and optical testing, every key production step is carefully controlled by Alteoptic. We also provide customized cable lengths, fiber types, connector interfaces, printing, packaging, and waterproof housing solutions to meet different FTTH project requirements. Thank you for visiting the Alteoptic production line.